My name is Kang Dong-ki. I want to find a paper about healthcare. Let's talk about conventional agents in healthcare. A systematic review. Research background. Several randomized controlled trials of intervention involving embedded conversational agents have shown significant improvement in physical activity, broad-chain vegetable consumption, and accessibility to health information. However, the majority of these agents only allowed for constrained user input, for example, multiple choice options. A recent renewed interest in artificial intelligence has seen an increase in the popularity of conversational agents, particularly those with the capability to use any unconcentrated natural language input. Research purpose. No systematic review of the use of the technology in healthcare has been undertaken, so systematically identified and review study of a conversation agent that use any unconstrained natural language input for health-related purposes, focusing on characteristic applications and evaluation method. They included primary research studies that focused on consumers and caregivers or healthcare professionals, and involved a conversational agent that use any unconstrained natural language input, and tested the system with human users. An evaluation measure presented in the included studies were extracted based on three types of evaluation: technical and user experience and health research. Technical, technical evaluation of a conversation agent included an objective assessment of the technical property of the system. User experience evaluation was considered a subjective assessment, where a group of users tested the system to judge its property or component based on their personal opinion. A health research was considered to involve any health-related result present in the included study, including process and outcome measures as defined by Donabedian. Donabedian published evaluating the quality of medical cures. An object screened by one investigator for test screening by two independent investigators. Coin copper was used to measure the intercoder agreement between individuals. The following data were stated for each study. Systematic review protocol was registered with Prospero. Prospero is an international database of prospectively registered systematic reviews with a health-related outcome. The characterization of conversational agent, the type of technology, and their dialogue management and dialogue initiative, input, output, and task-oriented. Especially dialogue management divided into three, and finite state is the usual taken through the dialogue consisting of a sequence of predetermined stepwise stages. Frame-based, the user is asked a question that enable the system to pair slot in a template in order to perform a task. The dialogue flow is not predetermined, but depend on the content of the user input and the information that the system has to elicit. Agent-based, It's to enable complex communication between the system, the user, and the application. Result. The database search retrieved and 1,513 citation of the title and abstract screen. Full text to screen is 121. After all, 15 included studies. The kappa statistics for the title and abstract screen was 0.53 for the full text screens. So they included 7 studies evaluating 14 different conversational agents with unconstrained natural language input capability. The characteristics of the conversational agent evaluated include studies. The finite state dialogue management was used in the design of 6 conversational agents, and for each those, the dialogue system controlled the flow of the conversation, open to support activities such as data collection for chronic disease management, while facilitating diagnosis through a predefined clinical interview guide. So frame-based dialogue management was used 7 agents, and for these agents, both the human user and the agent were able to read in the conversation. Agent-based dialogue management, the user reads the conversation, asking questions, and read to the mental and physical health. Evaluation measures were divided into 3 main types: technical performance, user experience, and health-related measures. The most commonly reported measures of technical performance were the proportion of successful task completion, 80% to 90% for 3 conversational agents, and recognition accuracy is 70 to 97% for 2 conversational agents. The most common conditions were related to mental health, which was the focus of 6 studies. 1 RCT objectively measured patients' reported outcome measures, depression and anxiety, using a validated scales and finding a significant decrease in symptoms of depression, a p-value below 0.05, and across RCT evaluated the diagnostic performance for depression of an embodied conventional agent compared to a psychiatrist. Finding of sensitivity 49% and specificity 93%. Despite the increasing use of conventional agent in other application domains, their use in healthcare is relatively rare, most published after 2010. Most of research in the area evaluated task-oriented conversation agents that are used to support patients and clinicians in highly specific processes. The study included in this in constantly reported technical evaluation measures for individual components of the conversation agent. User experience evaluation measures were also reported inconstantly and were mostly assessed using non-validated questionnaires. Health research evaluation measures, they found only one study evaluated the efficiency of a conversational agent on health outcomes using adaptive study design method and validated questionnaires. The remaining study uses study design with high risk bias as well as non-validated questionnaires or subject measures, which make validation and generalization of results challenging. Eligibility criteria were objectively defined and applied in the screening of each study by two independent research. The use of conversational agent with unconstrained natural language capability in healthcare is an emerging field of research that may have the potential to benefit health across a broad range of application domains, but evidence of efficacy and safety is still limited. Future research should strive to adhere to standards for reporting the characteristics of conventional agents and the method for evaluating their safety and effectiveness. Thank you.
I will introduce the paper in Real Conversations with Artificial Intelligence, a comparison between human-human online conversations and human chatbot conversations. The review will proceed in the order of introduction, method, experiment result, limitation, and discussion. Based on August 2015, efforts to model human language using computers have not been very successful over the past half century. This is a result of underestimating the complexity of human language, which makes it difficult for computers to understand the variability in the way words are arranged to convey the meaning of a language. However, modeling human language using AI technology can be used in various fields such as airline reservation systems. Therefore, computer-mediated communication has become an important research area to explore human language. One of the most popular CMC forms among teenagers today is instant messaging. Instant messaging is provided through mass media such as email and social network service. Compared to other standard communication formats, the characteristic of computer-mediated communication is its unique use of abbreviations. It is also characterized by a lack of signals of functions such as body language and voice tone. However, it has been found that CMC can communicate emotions better than face-to-face communications. Chatbots such as Ultra, Her, Alice, and Cleverbird are a new area of CMC, and users mainly interact with chatbots for small talk. Existing research on chatbot has focused on improving the ability to interpret human language and respond meaningfully. The authors seek to explore how users explicit and implicit communication of human language and human-computer interactions. Cleverbot, chosen by author for comparison, was one of the first chatbot launched on the internet by Lolo Carpenter in 1997. Cleverbot is designed to simulate natural conversations by learning human interaction based on feedback. Cleverbot passed the Turing test in 2011, and 59% of 1,334 experimental participants rated Cleverbot as a human. The author established the research hypothesis through the following three assumptions. First, people will feel less comfortable during conversations because they have less experience communicating with chatbots than humans. Second, chatbots will not have the ability to have goal-directed discussions and will have a limited depth of information on specific topics. Third, there will be no common history and experience in conversations between humans and chatbots. Based on the above three assumptions, the author established a research hypothesis that people will send fewer messages and use fewer words and vocabulary when communicating with chatbot. The author compared 100 random human-to-human conversations with 100 random human-chatbot conversations. The human-human data collected instant messaging conversations from undergraduate and graduate students at the College of Humanities in the Mid-Atlantic region. Also, the human chatbot data was provided by ClearBot creator Lolo Carpenter, a record of a user random past conversations. For effective analysis, the author removed less than 10 conversations and non-English conversations. The following is about the variables used in the analysis. The author analyzed 7 dependent variables. The 7 dependent variables are largely divided into 3 categories. For example, there are number of words per conversation, the number of messages per conversation, and average number of words per message. In addition, the author additionally analyzed 14 variables using the LIWC program. The LIWC variables consist of the number of words, the number of words per sentence, the percentage of words larger than 6 letters, emotional words, and sexual words. Also, the author used multivariate ANOVA and set p-value 0.005 as having a statistically significant difference. The following are the results of the experiment. As a result of the multivariate ANOVA test for 7 dependent variables, 4 variables showed statistically significant differences. Variables showing significant differences are message per conversation, word per message, type token ratio, and profanity. As a result of a multivariate ANOVA test for 14 LIWC variables, 8 variables showed statistically significant differences. People were found to use much more pronouns, profanity, social words, negative emotional words, and sexual words when communicating with Cleverbot. The summary of the experimental result of the paper is as follows. As a result of the study, human chatbot messages had much more profanity, and the number of words was lower than of human-human messages. which is consistent with the research hypothesis. Also, it appears that profanity is used on average 30 times more in human chatbot conversations than human-human conversations. In addition, humans talking to clever used an average of 4.29 words per message, and conversations with humans used an average of 7.95 words. But contrary to the research hypothesis, people sent more than twice as many messages to chatbot. Finally, limitation and discussion. This study has a limitation that demographic information could not be obtained because the conversations were collected by guaranteeing anonymity of students from one university. This limitation has limited in-depth analysis using demographic information, and there is a limit to the representativeness of the sample. The author discussed that future research could improve the above limitation and investigate the difference in conversation lengths by analyzing the physical time spent in each conversation and the silence time between individual messages. As a personal critique of the paper, it seems necessary to set up chatbots using super language models such as BOTS and GPT, which have recently achieved rapid development of language models using AI technology as a comparison target. Thanks.
Okay, hello guys, my name is Hong Kang, and this is the presentation for special seminar, which is interaction big data. And our team is team number 2, and our subject is the human agent interaction. Let's begin my presentation. And this is my title of the paper, which is Agent Based in Vehicle Infotainment, aka IVI services in IoT environments. And the keywords of this paper is IoT and IVI and master and agents. The purpose of this paper is develop a method for conveniently operating numerous IVI functions existing in the vehicle by drivers and passengers. And the second purpose is compare performance of the centralized IVI, aka CIVI function, and the agent-based IVI, aka AIVI function developed with the conventional IVI. With the growth of IoT technology and the automobile industry, various in-vehicle infotainment services have been developed in which user can exploit a variety of IVI devices such as navigation systems, the speakers, headrest display, and the heated seats. A typical IVI system is based on the peer-to-peer model in which the user will directly control each devices. Nowadays, a variety of technologies on autonomous vehicle have been extensively developed, including autonomous driving technology. In order to realize perfect autonomous driving, the connected technology that connects the cars and all things is necessary. In particular, the IVI services that been noted as one of the key services in the automobile industry. In near future, I think the people will be able to watch some VR movies through the streaming services provided in the vehicle. The currently IVI platforms tend to focus on the communication inside the vehicle, but however, the interworking with an external network also need to be considered together with the IoT communication and security issues. So this paper wants to discover when the IVI agent is used, the time for drivers and the passengers to use the IVI system is shortened, thereby providing convenience. So there is 3 types of the IVI. The conclusion of this paper is agent-based IVI, aka IVI is most convenient the system for the driver or passengers. So there are 2 research methods. The first one is comparison of TTD, aka total the transmission delay of the conventional IVI, etc. And the second research method is throughput, the comparison of conventional, the 3 things. The overcome the drawbacks of peer-to-peer model, the CIVI schemes was the recently proposed in which an IVI master is employed provided IVI services between user and drivers. However, the centralized model may give lower performance as the number of users and devices get larger. In addition, there are some limitations to reliable the connecting efficiently managing many autonomous IVI devices that were made by the different vehicle manufacturers according to their own infotainment ecosystem. For example, in case of the brand, the speakers, smartphone, etc., the mounted display seats, and so on. So if these devices are used by many users at the same time, or larger amount of traffic will be generated, and this may induce performance degradation in the CIVI system. So there are 2 hypotheses. The first one is IVI agent manages a group of IVI devices called a cluster. By clustering IVI devices according to the communication method can reduce the load given to the IVI master. And the second hypothesis is it can provide more efficient communication than the existing IVI system by applying the cluster-based constraint application protocol to IVI agent nodes. Okay, this is the conventional IVI system. Nowadays, the conventional IVI system is based on the peer-to-peer model in which the vehicle driver will directly control all devices in vehicles, such as navigation, black box, etc., like in figure number 1. So many automakers and information technology companies have so far developed a variety of IVI system and services as summarized in table number 1. These IVI system provide many distinctive services with user-friendly interface for each management. On the other hand, however, the current IVI system are based on the peer-to-peer or CIVI models, since there are a small number of IVI devices, at the most 10 in the system. So these paper researchers, the implementations, the two kinds of things. The first one is CIVI. In this work, the IoT-based, the lightweight, the machine-to-machine of aka LWM2M framework, aka I will call you LWM system framework, is used for communication between IVI master and IVI devices. So the CIVI system consists of IVI master, IVI user, and IVI devices shown as in figure number 2. In IVI user access the IVI master using a smartphone and the protocol system, the aka HTTP. The IVI master manages the IVI devices based on the LWM system, and the communication with the IVI devices use COAP. So the IVI master connected the IVI devices and the IVI client and manages all IVI devices on the vehicle. So IVI user can access the control the IVI devices only through the IVI masters. Okay, in CIVI system, user type are classified into car owner, the temporary owner, the private client, and the public client, shown as in table number 2. The car owner have the characteristic of long-term use and ownership, and the temporary owner may be a user with the car sharing or car rental service who has the ownership in the short term. So in addition, the clients can be classified into a public client with the short-term use, and the private client will be with the long-term use, for example, family members or friends. And this is the second implementation, which is AIVI. The AIVI scheme's purpose in this paper consists of the IVI user, IVI devices, and IVI agent, and IVI master. The figure number 3 shows the AIVI system architecture, which means the IVI agent is newly introduced for control and the manage of the devices within the same cluster, such as sensor devices and the contents. And the picture of the figure number 15 is the testbed configuration for the implementation of the purpose AIVI schemes. So this is experimentation and measure. In this section, the researchers discussed the testbed experimentation for the performance comparison with the existing IVI schemes. The TTD means the time duration in which the packet is delivered successfully. It was the noted TTD, which depend on how effectively the message are delivered and the processes in the IVI system. So the figure number 24 and the figure number 25 shows the TTDs of the 3 candidate schemes for the different number of user and devices and respectively. The figure the number 24, the peer-to-peer schemes gave the larger TTDs as the number of the user increased. This is because of the user has to perform the connected setup processes, such as time on new devices is used. On the other hand, in the CIVI, the user can control other devices through the master ads, and thus it shows the better performance than the peer-to-peer scheme. However, the CIVI schemes provide larger TTDs than the proposed AIVI schemes. This is because in the CIVI schemes, the processing load of the IVI master will get larger as the number of user increase. So on the other hand, the proposed AIVI gave the best performance among the 3 candidate schemes. This is because in the proposed schemes, the IVI agent are employed and direct communication between IVI user and IVI agent is used to performance improvement. And the last thing, the figure number 25 shows the TTDs for the 3 candidate schemes for the different number of IVI devices. From the figures, we see the researchers see that the proposed AIVI schemes provide the best performance as the number of the IVI devices increase, much more messages for registration and the communication will be generated. However, in the proposed schemes, the number of these messages can be reduced with the help of IVI agent that support the cluster of IVI devices. So the first conclusion is that with the help of IVI agent, performance can be enhanced and the loss of IVI master can also be reduced. And the conclusion is from the experimental research, we can see the proposed AIVI schemes provide better transmission delays and throughput performance that existing peer-to-peer and CIVI schemes, in particular in case there are 10 or more IVI devices in the vehicle by the hypothesis number 2. So I think the proposed agent-based AIVI schemes can be used effectively for IVI system with larger numbers of user and devices, as in public transportation, such as trains or airplanes, I think. And the limitations of this paper is in IVI systems with small number of users and devices such as cars. The proposed scheme tend to provide almost the same performance with the existing scene schemes. So we can discussion that about two things. The first is for further studies, a more enhanced the schemes need to be developed for IVI systems with a small number of user and devices with exploiting the features of the proposed AIVI scheme and the characteristic of IVI devices. And the second is this is necessary to consider whether the IVI system for future passengers cars will have different functions from the current IVI, or whether there will be a difference in quantity. Okay, thank you for listening to my presentation.
The title of the paper I will present is Human-Robot Interaction, Status and Challenges. This paper was published in 2016 and has been cited 359 times. Human-robot interaction is currently a very extensive and diverse research and design activity. The literature is expanding rapidly with hundreds of publications each year and with activity by many different professional societies and extraordinary meetings. Mostly in the technical disciplines of mechanical and electrical engineering, computer and control science, and artificial intelligence. While human automation interaction, for example, in piloting aircraft, has long been an active issue in human factors. To date, HRI has been relatively neglected by our community, though embraced by others identifying with, for example, human-computer interaction. In any case, the needs for research on human interaction aspects and participation in robot research and design are huge. Human factors professionals can obviously benefit by improved understanding of dynamics, control and computer science, artificial intelligence, but at least should find ways to collaborate with engineers in these fields in research, conceptual design and evolution. HRI can be divided loosely into four areas of application. First, human supervisory control of robots in performance of routine tasks. These include handling of parts on manufacturing assembly lines and assessing and delivery of packages, components, mail, and medicines in warehouses, offices, and hospitals. Such machines can be called telerobots. Capable of carrying out a limited series of actions automatically based on a computer program, and capable of sensing its environment and its own joint positions and communicating such information back to a human operator who updates its computer instructions as required. Second, remote control of space. Airborne, terrestrial, and undersea vehicles for non-routine tasks in hazardous or uh, inaccessible environments. Such machines are called operators if they perform manipulation and mobility tasks in the remote physical environment. in correspondence to continuous control movements by the remote human. If a computer is intermittently reprogrammed by a human supervisor to execute pieces of the overall text, such a machine is a telerobot. Third, automated vehicles in which is human is passenger, including automated highway and rail vehicles and commercial aircraft. Fourth, human-robot social interaction, including robot devices to provide entertainment, teaching, comfort, and assistance for children and elderly, autistic, and handicapped persons. In each of the four areas, author cites some background, describe exemplary ongoing research, and discuss research challenges. There is a huge variety of robots doing assembly line tasks, picking and placing, welding, painting, and so on. To the extent that human operators are required for the functions of supervisory control, planning, teaching, monitoring of automatic control, making repairs, and learning from experience. Such machines are telerobots. The Baxter assembly line robot is a marketed product by Wrestling Robotics in Boston. It is a widely discussed robot designed to be safe to operate in close proximity with people because it is mechanically compliant, much like the human body. And an interesting innovation in the Baxter robot is a displayed set of eyes not for the robot to see but rather for it to communicate to the human operator a sense of what the robot's program is currently attending to. Also, Baxter's arms can be made mechanically compliant, enabling a programmer to move its hand as part of teaching it a manipulation task or working in close proximity to people. Figure shows the winner at the ARPA from the Korean Institute of Science and Technology test, which clearly had legs with supplementary valves attached. In the medical arena, surgical telerobots such as the Da Vinci system are now permitting greater precision of the surgeon's hand motions for minimally invasive surgery. Physical handicapped persons are now experiencing improved manipulation and working prostheses and orthoses. Human factors research is needed to improve the fitting of such devices to patients as a function of their particular neuromuscular abilities and deficits. MIT's Kismet is an expressive robot head with social intelligence. According to researcher reports, using computer processing of the face and voice of another person, Kismet makes appropriate gestures in return. One can debate whether the technology is truly social intelligence, but it surely poses interesting philosophical questions. Evidence suggests that such devices are effective at eliciting normal social interaction with young children. However, one can wonder whether such devices inhibit healthy engagement rather than enhance it. A number of toys and therapeutic animal or human figures that are coming on the market embody computer-based speech recognition, and decision-making software. For example, Mattel has developed a new Barbie doll with an extensive speech and language recognition vocabulary that is linked via the internet to the company server. The door is designed to carry on an extensive conversation with young girls or boys in area of their interest. Conclusions. HRI is a rapidly evolving field. Specialized robots under human teleoperation have proven successful in hazardous environments and medical applications, as have specialized telerobots under human supervisory control for space and repetitive industrial tasks. Research in areas of self-driving cars, intimate collaboration with humans in manipulation tasks, human control of humanoid robots for hazardous environments, and social interaction with robots is an initial stage. The efficacy of humanoid general purpose robots has yet to be proven. Major human factors research challenges include A. Text analysis that includes dynamics, economics, and other factors. B. Teaching the robot and avoidance of unintended consequences. C. Considering how both human and robot have mutual models of each other. D. Use of robots in education. E. Coping with user culture fields and other value considerations. To date, except for aviation, the human factors community has contributed a very small fraction of the robotics papers in the literature. Essentially, all robots for the foreseeable future will be controlled by humans, either as teleoperators steered by continuous manual movement or as telerobots intermittently monitored and reprogrammed by human supervisors. Human-robot interaction is a rapidly expanding field with a great need to human factors involvement in research and design, especially as robots are challenged to undertake more sophisticated tasks. In any case, the first 90% of replacing humans with robots is much easier than the last 10%. Whereas the human race is changing very slowly. Computing and robots are uh, evolving at a very rapid pace. Therefore, specific conclusions about HRIA are likely to become invalid in a short time. The motivation of the HRI community seems more focused on building and demonstrating what works and provoking new ideas than in providing detailed and validated scientific conclusions. Thank you.
Hi everyone, my name is Yoon Na. Today my presentation topic is a human-agent interaction. Today I prepare one paper about human-agent interaction. This paper is encouraging deep self-disclosure through chatbot. And then this paper have three important keywords. First is self-disclosure and chatbot and mental well-being. This study is to investigate whether the self-disclosure of the chatbot affects the self-disclosure of people. And then after seeing this paper, I could find two important previous literature. First is a self-disclosure is a process in which a person reveals personal or sensitive information to others and is crucial for developing a strong interpersonal relationship. Second is when people were interviewed face-to-face by a human interviewer, they may tend to disclose fewer symptoms of depression than when interviewed by a virtual agent. So here is this paper researcher question and hypothesis. This paper has two research questions and two hypotheses. First, RQ1 is how do different chatting styles influence people's self-disclosure? RQ2, how do different chatting styles influence people's self-disclosure over time? And SQ1 is people's self-disclosure more deeply with a more self-disclosing chatbot over time. Hypothesis 2 is people feel a strong bond, trust, intimacy, enjoyment with a more self-disclosing chatbot over time. And then we have three conditions in these studies which come through in different level of chatbot self-disclosure. So that is from a no self-disclosure to a high self-disclosure. We want to see if the different levels of the chatbot self-disclosure could elicit user different self-disclosure. The conversation flow follows most of the chatbot design. Illustration of the study design. Standard questions are given to user during two sections. And the chatbot does not self-disclosure and only gives response about journaling and sensitive questions in these two sections. During small talk session, the chatbot gives low or high self-disclosure to participants from group 2 or 3. The second chat session consists of small talk. The two conversations about group 2 and 3 were designed to build trust and intimacy between chatbots and participants. And then to find out if it facilitates user self-disclosure. For HD, the chatbot gave a high level of self-disclosure through responses which included different feelings, thoughts, or information. In contrast, the chatbot responses for LD included more general responses and less feeling thought responses. Next, the conversation with three groups of chatbots were compared. Using LIWC calculated the word length of the journaling and sensitive questions chats. And then to investigate how chat styles and time factors affected self-disclosure depth during sensitive question conversation to code the data, adapted the categories and levels. Next, this paper using semi-structured interview and then question about the feeling and joy of chatting with the chatbot and asked to describe their feelings when answering sensitive questions. And then this paper using three measurement of three factors. One is trust. First is trust. Second is intimacy and enjoyment. And using 7-point Likert scales, and then using ANOVA to investigate whether participants feel a more bond with strong self-disclosure chatbots over time. Next is the result of this paper. LD and STD had similar January and January word counts to one another, but both were larger than those of ND. And comparison of LD and HD suggests that different chatting styles can influence the length of users' response to the same sensitive questions. In addition, ND members interacted less with the chatbot than others did, and their word counts were also lower. Here is the result of RQ1 and can be divided into two parts. First part is perception of interaction with the chatbot. Group 1 said feeling unfamiliar with the chatbot. Group 2 said like small talks increase motivation to answer sensitive questions in more detail in conversation with chatbot. Group 3 said since shared opinions and thoughts with the chatbot, truly can communicate with the chatbot, and then increase bond with chatbot. Second part is experience of answering sensitive questions. Many participants indicated that they could talk freely with it because they did not feel embarrassed to share their answers with a chatbot and felt comfortable self-disclosing with the chatbot to talking of sensitive topics. Here is the result of S2 and RQ2. First, S2 by examining the perceived intimacy and enjoyment of conversing with the chatbot over time. We found chatbot self-disclosure significantly affect the user bond with the chatbot. And trust level did not significantly increase for any group over time. RQ2, sustained interaction with chatbots. Group 1 said the chatbot asked them sensitive questions. Their conversation with the chatbot was, in general, a one-way street. So lack of interactivity became dry, gradual decline in user interest. Group 2 and 3 said most of these users that they felt more intimate with the chatbot over time and specifically mentioned that when they discussed deeper topics and they felt comfortable about giving in their answers. Next, here I give three discussion about this paper. First is a major contribution of our work is that our research saw an effective chatbot design that promoted deep self-disclosure over time. Second is this research not only show that the chatbot self-disclosure level has a strong effect on user deep self-disclosure over time, but also explain how factors contributed to the effect. Third is this finding extends knowledge of how chatbot design and the time influence user depth of self-disclosure, which benefit future chatbot design for mental well-being. And then here is two limitations about this paper. First is this paper not included participants who have severe mental issues. Second is only considered three constructs to explore two potential effects for self-disclosure. Thank you for your listening today. This is my presentation. If you have any question, please feel free to ask me or send an email to me. Thank you.
안녕하세요. 저는 팀 E 멤버 강동기입니다. 저는 강상규님의 Real Conversation with Artificial Intelligence, a comparison between human online conversation and human chatbot conversation에 대한 주제를 코멘트하겠습니다. 해당 연구는 사람이 대화 상대가 컴퓨터라는 것을 알 때 기존과는 다르게 의사소통을 하는가를 논리적으로 잘 분석한 논문입니다. 우선 표본에 관하여 이야기를 드리면 해당 논문의 클레버폿 유저는 다양한 사용자 가운데서 표본을 추출하였지만 연구에서는 한 지역의 학생을 대상으로 표본을 얻었고 이는 성별이나 나이, 사회적 계층, 지역 등 인구 통계학적 정보를 전혀 고려하지 않아 대표성이 부족하다라고 생각합니다. 언어는 이제 무엇을 말하는가와 어떻게 말하는가에 따라 대화가 진행이 되는데 이는 학습되어져 있는 에이전트에 따라 이해하는 것과 출력이 다를 것이며 클레버폿도 하나의 에이전트만으로 결론을 내리기보다 다른 에이전트들도 같이 이제 비교를 하면 좀 더 합리적인 결론을 지을 수 있을 것 같습니다. 감성 분석은 텍스트 데이터를 수치 데이터로 바꾸는 가장 좋은 방법 중 하나이지만 사전에 따라서 다양하게 해석될 가능성이 있습니다. 해당 연구의 결과 중에 사람과 챗봇이 의사소통보다 사람과 사람이 의사소통 시에 긍정적인 감정 단어를 사용한다는 것에 흥미로웠으며 이에 대한 학습 즉 긍정적인 감정 단어를 선택하여 대화가 지속되는 에이전트를 사용 시에 우울증 증상을 가지고 있는 환자들에게 지속적으로 노출 시 긍정적인 효과를 얻을 수 있을지도 차후에 연구가 가능한 흥미로운 주제라고 생각을 합니다.
안녕하세요. 강상규입니다. 저는 휴먼 로봇 인터랙션 스테이터스 앤 챌린지스 페이퍼에 대한 비평을 진행해 보도록 하겠습니다. 본 논문은 인간 로봇 상호작용 HRI의 현재 상태를 검토하고 다양한 연구 과제들에 대해 설명해 주었습니다. 특히 저자는 인간의 라이프 스타일 관점에서 인간 가치와 관련된 분야에 대한 연구가 HRI의 가장 중요한 분야라고 지적했습니다. 올해 상반기에 좋은 기회가 생겨 기업에서 연구개발 중인 자율주행 자동차, 메이크업 추천 및 화장품 판매 로봇 등의 시연을 본 적이 있었습니다. 그때 가장 기억에 남는 로봇은 음식을 만들어 서비스하는 로봇이었습니다. 이 로봇의 시연을 보고 제가 처음 느낀 감정은 신기하다였습니다. 하지만 그 다음에 든 생각은 과연 이 로봇이 상용화되어 매점에 배치된다면 호기심에 처음 방문한 고객들이 지속적으로 이용할까? 였습니다. 이러한 점에서 저자가 지적한 인간 가치와 관련된 분야에 대한 연구가 중요할 것 같다고 생각하였습니다. 또 한 가지 비평은 본 논문을 보며 제레미 리프킨의 노동의 종말이라는 책이 생각났습니다. 책의 간단한 줄거리는 인류는 편의를 위해 다양한 기술을 진보시켰고 진보된 기술은 풍요와 빈곤을 낳는 결과를 내었다는 내용입니다. 제레미 리프킨이 주장한 효율, 능률이라는 가치를 향상시키는 것은 기계가 하게 될 것이고 개인들은 자유로운 삶을 살게 될 것이라는 명분 아래 경제적 능력을 박탈당할 수 있는 가능성이 생겨 기술의 진보로 인해 변화될 사회 속에서 개인들이 맡을 수 있는 역할을 재정의해야 한다는 것이 먼 미래의 이야기는 아닐 수도 있겠다는 생각이 들었습니다. 감사합니다.
네, 안녕하십니까. 저는 빅데이터 세미나 팀 넘버 2의 강동섭입니다. 먼저 저는 강동기님의 Conversational Agent in Healthcare 발표에 대한 크리틱스를 하게 되었습니다. 먼저 논문에 쓰인 방법론과 이제 검증 과정이 매우 명확히 잘 전달되었던 부분에서 해당 논문이 전달하고자 하는 목적을 잘 파악할 수 있었습니다. 하지만 Conversational Agent in Healthcare 분야가 의료 분야라는 세분화되고 전문적인 분야이기도 했고 또한 리뷰 논문이었기 때문에 논문에서의 비교 과정에서 언급된 이제 핵심 키워드였던 Conversational Agent라든지 Embodied Conversational Agent 또는 Unconstrained Natural Language에 대한 컨셉적인 부분에서 자세히 다뤄지지 않았던 점은 저처럼 해당 키워드를 처음 접하는 청자로 하여금 한 번에 이해하기는 다소 어려웠던 점이 아쉬웠습니다. 또 해당 논문의 한계에서 나타났듯이 우울증 감소의 이제 유효성을 나타낸 논문이 한계였던 부분은 매우 아쉽게 느껴졌고요. 해당 의료 분야에서의 컨버세이셔널 에이전트 표준화가 필요해 보인다고 생각을 했습니다. 이를 통해서 헬스 릴레이티드 메저 부분에서 보다 유효한 논문들이 앞으로 많이 리뷰되길 좋겠다라는 생각을 했고요. 컨버세이션 에이전트가 상담 중에 이제 임상 의사를 지원하거나 또는 소비자의 행동 변화를 지원하고 또는 생활 환경에서 환자와 노인 등 이제 개인을 지원할 수 있다는 부분에서 이점과 동시에 잠재적인 의학적인 안전 문제를 동반한다는 문제를 생각을 했습니다. 해당 논문에서 언급됐듯이 당시에는 의료 분야에서 컨버세이션 에이전트가 기술에 대한 체계적인 검토가 이루어지지 않았던 시대였지만 최근에는 건강과 관련된 의료 분야에서 의학적인 목적으로 자연어 처리에 제약이 없고 응용하고 해당 기술의 성과를 평가하는 방식을 활용한 이를테면 인공지능 심리 및 감정 분석 서비스인 조나단 또는 트러스트 서비스가 떠올랐습니다. 코로나19의 영향으로 요즘 무기력함 또는 우울증을 겪는 현대인들이 많아졌고, 이런 상황을 일컬어 코로나 블루 현상이라고들 하는데, 지금도 계속되고 있고, 앞으로 우리의 일상에 많은 영향을 미치는 코로나 블루 현상을 극복하기 위해 2020년도에 오라클에서 조사한 인공지능 심리 및 감정 분석에 대한 필요성을 11개국 1만 2천여 명의 사람들에게 조사한 결과 80% 이상의 사람들이 치료사나 상담사를 컨버세이셔널 에이전트와 같은 로봇으로 대체하는 것에 찬성을 했고 그중에서 한국인의 찬성률은 약 87%였던 점을 감안을 했을 때 이처럼 컨버세이셔널 에이전트가 일상생활에서 업무적인 도움을 주는 것에 그치지 않고 헬스케어 부분에서도 표준화된 평가 방식을 적극적으로 활용해서 보다 안정된 일상을 경험하는 날이 다가오길 기대한다고 이번 발표를 통해 느꼈습니다. 저희 크리틱스는 이상으로 마치도록 하겠습니다. 감사합니다.
안녕하세요. 팀2 나연선입니다. 현재 IBI는 자율주행과 함께 성장하는 매우 흥미로운 주제라고 생각합니다. 그렇기에 저는 이번에 강동섭님의 Agent Based in Vehicle Infotainment Service in Internet of Things Environments에 관한 논문에 흥미를 느끼고 코멘트를 준비했습니다. 먼저 본 논문에서는 효율적으로 IVI 시스템을 사용하기 위해 두 가지 IVI 시스템을 설계했습니다. 첫 번째로 설계한 IVI는 중앙 처리 장치를 중심으로 한 CIVI, 두 번째는 에이전트를 기반으로 한 AIVI입니다. 저는 본 논문을 보면서 IVI라는 시스템에 대한 개념과 이후 IVI가 자동차 산업에 적용될 수 있는 가능성에 대해서 매우 인상 깊었고 흥미를 느꼈습니다. 하지만 본 논문에서 아쉬운 점이 있다고 생각합니다. 먼저 본 논문의 가사를 살펴보면 에이전트를 기반으로 한 AIVI 시스템을 사용하게 된다면 과부하가 적을 거다. 결론적으로 AIVI 시스템은 과부하 저하에 도움이 되지만 적은 인원이 탑승할 때에는 AIVI가 크게 도움이 되지 않는다는 것을 알 수 있었습니다. 그렇기에 본 논문은 자동차를 대상으로 한 IVI보다는 더 많은 인원이 탑승하는 기차나 항공에 더 적합한 논문이지 않았을까라는 아쉬움이 남았습니다. 감사합니다.